Welcome to this video on the basics of galvanic cells and cell potential. Today, we will explore the fundamental principles behind how spontaneous redox reactions can generate usable electrical energy, covering anodes, cathodes, ion migration, and voltage. At the core of electrochemistry is the concept of spontaneous chemical reactions. We can harness the energy from these reactions by physically separating the oxidation and reduction half cells, which allows us to capture the flow of electrons as usable electricity. Understanding the dynamics is simple. The anode is the site of oxidation, where metal atoms lose electrons and dissolve into solution. The cathode is the site of reduction, where aqueous cations gain those electrons and deposit as solid metal. A galvanic cell consists of several key components: the external wire for electron flow, the half-cell beakers, the electrolyte solutions for ion mobility, and a voltmeter to measure the cell potential, or electromotive force. The salt bridge is critical for three reasons. It maintains charge balance by preventing ion buildup. It facilitates necessary ion migration, and it completes the circuit, keeping the bulk solution separated while allowing continuous flow. Consider the classic Daniell cell. Under standard conditions, it generates a potential of 1.10 volts. Because this standard cell potential is positive, we know that the overall redox reaction is thermodynamically spontaneous. To calculate cell potential, use the master formula. E cell equals E cathode minus E anode. Identify the cathode as the species with the more positive reduction potential. Remember, cell potential is an intensive property. Do not multiply values by stoichiometric coefficients. This chart illustrates various standard reduction potentials. Generally, species with higher potential values are stronger oxidizing agents, acting as cathodes, while those with lower values act as anodes. Here, we can compare different cell configurations. Notice how the calculated standard cell potential changes based on the specific metal combinations used in the anode and cathode reactions. The operation of a galvanic cell follows a set sequence. Oxidation starts at the anode, electrons travel through the wire, reduction occurs at the cathode, and the salt bridge balances the charge to maintain flow. To wrap up, remember this golden rule: an ox and red cat. This simple mnemonic reminds us that oxidation always occurs at the anode, while reduction always occurs at the cathode. Thank you for watching. We hope this video helps you in creating high-yielding STEM content for our channels. Feel free to reach out to us at our social media handles shown here.